going to go over homework 9 for 2-sample tests. So let's start with question number 1. What is the Excel function for a 2-sample t-test with dependent samples? So when we use the Excel functions, it's the same function for both an independent and a dependent sample. Remember, we specify in the parameters of the test what type of test we're doing, and that is going to be the t-test function. Question number 2. Researchers want to test the effectiveness of a new drug at treating hypertension. They have 100 participants who are divided into 2 groups. Group 1 receives a standard hypertension drug, and Group 2 receives the new medication. After 1 month, the blood pressure readings of each group are measured. What is the appropriate test to use? So here I have 100 participants. I'm dividing them into 2 groups. So I have 2 samples. And then I need to think about whether the samples are independent or dependent. And in this case, half are going into one group and half in the other, and they have no relationship to each other. So that would be independent samples. So let me just look at the criteria. A 1-sample z-test, that would be comparing 1 sample to a population. So that doesn't fit here. 2-sample t-test for independent samples, yes, because I have 2 samples and they're independent. A 2-sample t-test for dependent samples, no, because the groups are not dependent groups. Okay, question number 3. You have a sample of 45 third graders who took a reading comprehension test before and after participating in a reading program. The scores on the reading comprehension test are then compared. What is the appropriate test to use? So let me look. A 1-sample z-test, no, because that would compare 1 sample to a population. A 2-sample t-test, possibly, because I do have 2 samples. I have a before sample and an after sample. However, independent samples, it's not an independent sample because it's the same people before and after a program. So that would be a dependent sample because I have a pre-test and post-test on them. So this would be a 2-sample t-test for dependent samples. What is the appropriate measure of effect for a 2-sample test? And we talked about in class how the Cohen's d is going to be the measure of effect that we're going to use for 2-sample tests. Use the following information for problems 5 through 9. A group of 25 people were asked to remember as many items as possible from a list before and after being taught a memory device. Researchers chose alpha equals 0.05 level to test their results. Okay, and we have an Excel file with this data. I've already opened the data file, so go to that in just a minute, but let's answer the first question so we know what test we're going to use. So what is the proper test to use? So let's think about this. We have 25 people, and they're being tested before and after being taught a memory device. So pre-test, post-test. So that's going to be a 2-sample t-test for dependent samples. I've got 2 samples, and it's the same people before and after. The next questions are all going to come from my test results. So let's go ahead and go to Excel and run those test results. And I want the 2-sample memory. Okay, so here's the data. So before and after being taught a memory device. So I can do the analysis tool pack for this. It's going to be the best option because it'll give me all the results I needed. So let me go to data analysis. And this is exactly the test I want, t-test for a paired sample. So I'm going to do before. And it's remembering because I just recently ran a test for something else. It's remembering what I had in there for that other test. So the data range is close, but not quite because I have more data points for this one. So let me check the data points now. So A1 through A26, that's correct. And I did select the labels. Remember, we just leave this box blank. And I'm using the 0.05, so I don't need to change that. And then I want my output range to be near my data somewhere, and I have it going into cell D8 right now, so that's good. I can also just come here and click wherever I want it to be. Click OK, and I get all of my results here. So now let me go back to Blackboard to the test, and I need to answer what is the degrees of freedom for the study. So I could figure that out just by taking the group of 25 people, and with pairs we're going to take number of pairs minus 1, or I could come over to my results and it tells me 24 is my degrees of freedom. And the next thing I need to know is what is the test statistic. So let me come back over here, and it gives me my test statistic. It is negative 3.133. So that would be one of my options. True or false, this finding is statistically significant. Well, to figure that out, I'm going to compare the level of significance that I set to my p-value. So I'm just going to type this in for me. It just helps me keep track of what my significance level was. So my significance level I used was 0.05. And in this case, I'm looking to see, let me go back to my original question that I'm being asked. So this actually is not specifying whether it's just a difference or it's increasing, but if you're looking at before and after, it makes sense that you want that to be increasing. And in either case, my p-values are very small, so it wouldn't make a difference. But let's look at the p-value for one tail, which is 0.002, and compare that to my level of significance of 0.05. So it's lower than my level of significance that I set. So my conclusion would be to reject the null hypothesis, and then true, this would be statistically significant. So based on this information, I am making the decision to reject the null hypothesis. When the p-value is lower than the level of significance, I would reject the null hypothesis. And again, even though it didn't specify direction, both of these are under 0.05. Let's go to number 10. A group of 44 women with gestational diabetes were assigned to one of two groups. Group 1 received standard care, and Group 2 participated in group counseling visits. Researchers wanted to determine whether or not the birth weights of the infants of mothers who participated in the group counseling visits were significantly different than the birth weights of mothers who received standard care at the alpha equals 0.05 level. Okay, so we have an Excel file, so let's answer which test we're going to do, and then we'll go to Excel and run the test. So we have 44 women being assigned to one of two groups. So we have two samples, and those samples are independent because they could have been put into one group or the other group. They could have gone to either Group 1 or Group 2. And Group 1 gets standard care, and Group 2 gets group counseling visits. So what's happening in one group is not impacting what's happening in the other group. So these are independent. So this is going to be a two-sample t-test for independent samples. And let's actually go to Excel to run the test. So I just need to find that file real quick. Okay, so here's my birth weight data. So I'm going to run this using the ToolPak. Let me go to the Data Analysis ToolPak. And this is not going to be a paired sample. That's what I just did last time, so it's already highlighted for me. But in this case, I have two samples. And what I need to know is, do I do equal variance or unequal variance? Well, to answer that, I need to figure out the variance. So let's back up a step and figure out the variance for each group. And I'm just typing this in here to help keep me on track with what I'm doing so I don't look at this and forget what those numbers are. So I'm going to do this with the function. So I'm going to insert function. And it's showing up because I've used it recently. Otherwise, you would just search here for it. And I want var.s because that tells me for my sample. Okay. and I need to tell it where that data is located. And here's my data range. And I need to do the same thing for group 2. And so my rule of thumb is if the variance of one group is not more than double the variance of the other, I would assume equal variance. Now these are both really long decimal points, so I just want to truncate that a little bit so I don't have wrong fraction, quite so many decimal points. So here we go. This makes it a little bit easier for me to do that comparison. So the variance here is 129,918, and my variance here is 134,837. So they're pretty close together. Definitely not double. One's not more than double the other. So I can just assume equal variance. And these look large, but this is birth weight in grams. And so I'm going to have a range here from, I've got 43.95, and I've got some lower values in here too. 4,500 grams is roughly about 9 pounds. So some of these are pretty big babies. So now that I know that I can do equal variance, let's go to the tool pack, and I'm going to run the t-test for equal variance, 2 sample with equal variance. And I need to select my range of data. Okay. And then I need to select my range of data here. And I did choose label, so I need to check that. And I need to select my output range. And click OK. Okay, so now I have my results. So let me take a look at these results. And I'll actually make this a little bigger, and then let me go back to Blackboard to see what questions I needed to answer about that. So I need to know the degrees of freedom for the study. So it tells me here in my results, my degrees of freedom is 42. I could also figure that out using our formula, which is for 2 samples, sample size of group 1 minus 1, sample size of group 2 minus 1. So it would be 22 minus 1, or 21, plus 22 minus 1, or 21, which would give me 42. But it also gives me that answer here, so it's going to be 42. And I need to know what is the test statistic. So here, my test statistic is 2.3, we're going to round that up to 2. So 2.32. And then true or false, this finding is statistically significant. So I'm going to look at my p-value to make that determination. And remember that the significance level that we set was 0.05. So let me just put that, sorry about that, I'll put that in here. So if I have a significance level of 0.05, I'm going to compare that to my p-value. Now let's go back to the question to see what it was actually asking us. So I just want to see if there's a difference. So here I'm looking at a two-tail test. So let me go back to my Excel data and look at the two-tail p-value, which is 0.025, and compare that to my level of significance, which was 0.05. And that tells me that it is lower than the level of significance, which means it is statistically significant. And because of that, I'll reject the null hypothesis. When my p-value is lower than my level of significance, I will reject my null hypothesis. So the next thing that I need to figure out is the effect size. So I have here the formulas for effect size that we went over in class. I can either use the formula and I can plug the information in by hand, or I can use one of our calculators to figure out the effect size. So I'm going to use this calculator, the danielsoper.com calculator, to figure out the effect size. So if I go to this calculator, it needs to know some information. It needs to know the mean. And I'm going to just kind of play with this to get it so I can kind of see both of them at the same time. Okay, so I want to be able, there we go, I want to be able to see these answers at the same time. So I'll make this this. I have two screens, so I can actually see it all, but it's harder to get it all into the recording window. So I need to know the mean from group 1, so I'll put in 4466. I'm going to go ahead and round that to 14. And the mean for group 2, so I'll put in 421205. And then I need to know the standard deviation. Note that I actually have the variance here, not the standard deviation. So I need to figure out the standard deviation. So I can just go to a calculator to figure that out. So let's pull my calculator over here. The variance for my first group was 129918. Let's just round that to 89. And I need to take the square root of that, which gives me 360.44. Put that in here. Now, this calculator likes to have both of the standard deviations to work, so I'll go ahead and find out the variance for the other standard deviation. So the variance is 134,837.3, and I need to take the square root of that, which is 367.2. Just going to, and I'll click calculate. And that gives me 0.698. So let's go back to Blackboard. So I got 0.698, which I can round up to 0.70. And then let me look at how to interpret that. That's going to be in those slides that we had in class. So let me open that back up. And I have this guide on how to interpret. And I have a medium effect being 0.50 to 0.79. And my effect I calculated was 0.70. So I'm going to interpret this as a medium effect. And that is how we do homework, the homework on T-sample for dependent samples. We will talk about it in class, but just the ones that you have questions about. So come with any questions if you have them, but hopefully that gave you a good overview on how to do the homework.